Okay, so I was just going to do this quick presentation, and I'm going to try and keep it as brief as possible. It's about backup strategies for photographers, and unfortunately, everybody these days needs a backup strategy. You need to back up, but photographers are a little different from other people in that we produce 500% more data than anybody else. So we can't rely on some of the things that our peers who don't take pictures can. So I'm going to go through some of that. I'm going to quickly explain what a backup strategy is, how to devise and implement your own, and we'll talk about some useful hardware and software options. But I'm not going to tell you specifically what you should do, because there's no right or wrong answer to this one. Everybody is different, and it's just like when you devise your own digital workflow. Your backup strategy is just part of your digital workflow. You just take from this presentation what you need. Unfortunately, it's not a very interesting subject. We'd all much rather be looking at pretty pictures. You know, in the same way that we'd rather be taking pictures, I'd rather be talking about photography than talking about backups. It's something we've got to spend some time on, unfortunately. You'd much rather be like taking pictures or editing them, but if your data is at all precious to you, you have to just set some time aside to work out what you're going to do to keep that data safe. Back in the old days, there was this hypothetical question, if your house is burning down, what is the one thing you're going to take with you? And after family members and pets, the one thing people would always say is our photographs. And we'd always be, those what to take with us, our albums and our photographs and our negatives. And we've got to think about our digital files in the same way. Your house probably won't burn down, but your hard drive will. I don't want to be alarmist, but your hard drive will fail. In the same way as your car has a finite number of miles on the engine, your car, eventually one day, your precious car that you spent $40,000 from BMW for is going to end up in the scrapyard. And we hope that by the time it gets there, you've done with it, and you've had your useful life, and it doesn't fail on you when you need it. But it's going to end up there. In the same way, your hard drive is going to pack up one day. It's going to stop working. And we hope that when that happens, your computer is in the basement and you don't need it anymore, and you've moved on to the next one. But hard drives are not what we would call solid-state components. If electronics solid state, it means nothing moves. Hard drives, they move. They move really fast. They spin. These days, they're spinning at more than 7,500 revolutions a minute, and based on platter size, I worked it out, it's about 75 miles an hour. And they can be doing that 24 hours a day if you don't let them shut down. 24 hours a day, spinning 75 miles an hour. They can't last forever. So it used to be you could buy hard drives with 10-year warranties. So I challenge you to find one that's got a 10-year warranty now. The longest warranty you can get is 3 or 5 years. And even then, they're not going to give you your data back. They'll give you a new hard drive. We don't want the hard drive, we want the data. I'm the voice of experience. This little pile of disks here is what's failed on me over the years. I've never lost any data, but I've lost hard drives all the time. So I looked on the web. Any idea what percentage of people on the web have lost data? 70% of people say that they lost data. We've already heard a lot of people here have had disks die. The first time it ever happened to me was a long time ago, and I lost data. And it's way before digital photography, and I swore it would never happen again. So since then, I've had backup strategies, but I didn't give them this grandiose name then. I was backing up my data. That has evolved over the years. So it used to be to floppy disks. Now, 1.4 megabytes, I think, isn't it, per floppy disk? And that's not a lot of data. It's not going to even hold a picture these days. This is inside your hard drive. This is why it fails. They're called a hard drive because this thing here is the drive, and it's hard, as opposed to our floppy drives. Basically, it's a magnetic media, so the same as VHS tapes or your floppy disks or any magnetic media. It basically switches on and off by pulsing magnets against this thing. This thing is spinning, as we said, at 7,500 revolutions per minute. A platter, or platters. Here there's a stack of 4 here. They have a head on the top and the bottom, and it might look like a record player. It's the same technology. It's the same idea. Like this spins. This is the equivalent of the needle, and it moves around, and it picks up the data in different sectors of your disk. Hopefully, these heads don't touch the disk. If they touch the disk, the tolerances are tiny. This thing is spinning very quickly. This arm with the head on is moving back and forward very quickly. And because of the speeds involved, it shouldn't actually touch. There's like molecules of air between the head and the disk. Or there should be. But occasionally, when you start to hear, it's not a good sound. We call it the click of death. We have the arm. The arm can fail. It's moved back and forward by motors. The head can hit the disk. It can fail. The spindle in the middle, that's basically a bearing, electric motor in there. The motor can burn out. The bearing can fail and it can freeze. The platter can get scratched. The whole thing can get hot. Heat is your enemy. It'll kill your hard drives. The board, which is on the bottom of those things, that can fail, burn out, and you basically, any of those things will happen. It's not worth fixing the disk. You've lost your data. Yeah, quick preventions are heat. To keep your hard drives cool. So if you have a computer case, it sounds stupid, but vacuum it. Keep dust bunnies out of those grills, because if it's air cooled like a bug, like a VW bug. It's not water cooled like a BMW. So it's pretty primitive. And if the air is not moving around in there, the hard drives heat, but lots of things heat. But the hard drives will heat up, and it's not good for them. Turn off your disks when you don't need them. Turn off your computer when you don't need it. They're spinning. Some people will claim that actually puts more stress on them, but I think that it's actually better for them to be turned off and cool down. You'll see drives that are called green drives and smart drives. And they switch themselves off when they're not needed, which is a lot better for them. So other things to do are always use surge protectors on everything electronic. Use surge protectors on your computers, on all your hard drives. Use battery backup. So if you do lose power in your house, you don't want your computer just turning off. It's not great for any component, but it's especially bad for hard drives, just to turn off. Keep your OS, keep the automatic updates installed, keep your virus protection, your firewall installed. All these things are common things in malware software. It should all be up to date. So we know that disks fail. All your data is on hard disks. There are solid state hard disks these days, but they're really expensive. They're not big enough for photographers yet. The big ones are 200 gigabytes or something, and they're expensive. So they're great for installing your operating system on, but they're not big enough to store all your data yet. Now, 10 years from now, we might have hard drives that aren't spinning in all our computers. So then we won't have to worry quite as much, but even your flash drives, they fail. So flash drives, if they're written to and from enough times, they actually start to fail. It's a lot, and you'll never hit that number, but if you start using it as a hard disk, you might. And unfortunately, we know a disk is going to fail one day. The manufacturers are going to help you a little bit, but it's your responsibility. There's no one backing up your data for you. You have to do it. So this is an unfortunate truth. So you've got to come up with this backup strategy, this big thing. I looked up on Wikipedia the definition of a backup, and it says backing up refers to making copies of data so that these additional copies may be used to restore the original after a data loss event. So that's what we know what it means. It's just basically we're copying our data from one place to another. And a backup strategy it can be a series of backups. Unfortunately, all our data isn't just in one place anymore. It's not like we can copy one hard disk to another and that's it, we're done. Most of us have data all over the place. So the characteristics of a good backup strategy are, one, it's simple. So if it's not simple, we're not going to do it. We're not going to be able to keep tabs on it. We're not going to be able to see when it fails. A good backup strategy is going to have an automated element. In other words, it should be backing up your data without you doing anything every night or every week at least. We also want to have an offsite element to your backup. So it's no good if you back up your hard drive and then store it by your computer and your house falls down, or someone comes and steals your computer and steals your backup as well. Your backup's got to be somewhere else as well as in your house. So we're going to talk about that. It might have an historical element. So there may be a way that you can go back and see what your disk looked like a year ago or something like that. This is a nice to have, and Apple users will talk about, you get this for free. So we want to back up the backup. It's not good enough just to back up once. So we'll look at the bottom. If you take anything away from this, my recommendation is all your data should be copied 3 times, and it should be in at least 2 physical locations. So you can't and when I say it should be copied 3 times, it shouldn't be copied from one disk to the same disk. It's got to be on 3 separate disks somewhere. And one of those should be out of your house. And the last thing is, it evolves. So I talked about when I first started backing up, I backed up to floppy disks, and then we backed up to CDs, and then DVDs. And now nothing's big enough, so we're backing up to hard drives. But it may change, so you've just got to keep evolving your strategy as long as you evolve your workflow. Okay, and it's relatively simple, but all you've got to do to create a backup is you first sit down with pen and paper or notepad or whatever it is, and you devise what your backup is going to be. And when you do that, you decide what you're going to back up. So we'll talk about each of these steps in a second, but basically we're going to decide what you're going to back up. You're going to find all that data because you can't back it up if you don't know where it is. We're going to find out if we need any new hardware to implement our backup strategy, and what software we need to do this. I'm going to show you some examples of some free stuff or cheap. Then we're going to implement it, and we said we have this automatic element, so we're going to set up something that's happening daily, and it's incremental. Incremental meaning that we only copy what's changed from one backup to the next. So it doesn't take very long. And then we're going to set up some sort of periodic offsite routine. So this is a more manual step, and unfortunately you're going to have to put this in your calendar or something, but just keep on top of that. And then finally, we're going to test and revise. So does your backup strategy still fit your needs? It's a question you've got to keep asking yourself. Does it still work? It's no good if you think you're backing everything up and then your computer dies and you find out you're not. So you've got to test that it actually works. What are we going to back up? So you can back up your whole machine. That's what we call full system backup. I don't find this very useful. The idea is if your computer dies, you can get another one and you can restore, or you can get another hard drive disk and you can restore your system from your backup. If my system has died, and it's happened to me once or twice, I rebuild everything from scratch. So I install the OS again, I install my applications, I put my data in place. I don't want to copy like a 4-year-old version of what my system is back onto a new system. So I would say the things that you want to be looking at to back up are all your documents, and we'll talk about documents as being separate from our media. And our media is going to be our photo. It's going to include our photos, but it's going to be video as well. Of course, if anyone's started taking HD video, you think that your 20 megapixel files are big. Once you start taking video and editing that, then things should just eat up hard disks really quickly. We're definitely going to back up our application data. So what's application data as opposed to media? Our Lightroom catalog. We're going to make sure we back that up. We don't want, we can save all our raw files, but if we lose all that work that we've done in Lightroom, that's a real bummer. So it's like losing half of your work. So you've got to back up. That's the kind of thing that application data is. It's your Lightroom repository, all your actions that you've created or downloaded that are saved into Lightroom or Photoshop or Aperture. Finally, we might want to be taking the system snapshot, which I don't do. This graphic here there's a free piece of software which I'll put on the website called JDisk. And it's kind of interesting to run. If you run this against you run it against one hard drive at a time, it will actually tell you distributed what files are taking up the most amount of space. So you can see, all those BitTorrent episodes of Top Gear that I put on my hard drive are suddenly eating up like 50% of my space. Quite often when you get a new computer, it's partitioned. And partition means they take a disk and they make it look like 2 disks, but it's still 1 disk. So that's not good. You need a second physical disk. And it's very easy to fit. But these days, it's very easy. You plug them in, your OS sees them, and you tell it what you want to do. You first, when you're working out what your backup strategy is, work out what you're going to back up. And, at the minimum, you're going to back up your image files. You want to back up that repository data from Lightroom or Elements. And those applications will actually create backups of themselves as well, but they're going to put them on the same disk. You want to make sure that you've got those backed up somewhere else. Your documents and things. I'll quickly give a shout out. The documents, when we're just talking about Word documents and presentations like I have here, or your spreadsheets, you'll hear people talking about the cloud these days. So the idea is that you don't store these things actually on your PC anymore. They're actually out there in interweb. I use Google Docs, and it means that if my disk dies, my documents still go on. It means I can access my documents from anywhere at any time, from my iPad, from my iPhone, from my laptop. As long as I can get to the internet, I can get to my documents. It would be great if we could do the same thing with pictures. And people will tell you that you can back up to these on-site, these interweb backup things. You pay them $100 a year and you can upload as much as you want to their site to back up. The problem is, I have the middle-of-the-road DSL. I can only upload 0.6 megabits a second, which is not nearly fast enough to be able to upload terabytes of data to this. Yeah. So the first thing is, again, once we've worked out what we're going to back up, we need to know where that stuff is. Modern OSs like Windows, you have my documents. I know in Windows 7 now they have this thing called repositories, they call it. It's basically, you have a repository which is your documents, a repository which is your pictures, one that's your music. And in Apple, I know the same sort of thing. You have this thing where all your documents go. The problem is, you've got to know what that relates to on your disk. So, for example, you've got to know physically where all these things are. So you've got to know physically where they are. You don't want to be backing up my documents. You actually want to be backing up disk locations. So find all those locations. And it's not a small task. But basically, you need to know all the disks. And the problem is as well that some of these programs that try to help you download your pictures from your flash drives onto your hard drives will start putting them in places you don't expect.
That's right.
So you've got to make sure that you know where they're going all the time. And, Lightroom is easy. It tells you specifically where it's putting it. But like I have a flip video camera, it'll start putting videos where it thinks they should go. Different users. If you have different users on one computer, you've got to make sure that you're backing up everybody's data. Otherwise your wife gets really upset when the machine crashes and you go, well, my data's safe. I was just thinking about this the other day. This is how my life was simple once upon a time. I had a modem and I had a computer. And this is how it looks these days. I'm a geek, so I have a lot of stuff, but, I have I have a modem, and it doesn't go to a computer anymore. It goes to a router, and because the router isn't powerful enough to cover my whole house, I have a wireless access point going downstairs, and then I have my computer, and I have my wife's computer, and of course Windows and Apple, because it would be too easy if everything was the same operating system. And then we have his and hers laptops, Windows and Apple again. We have my work laptop when I bring it home. These days we have iPhones, of course, and we have iPad. We have servers, so you have Apple Time Capsule and my Windows Home Server. We have network attached storage, NAS drives. Even these days, my TV, TiVo is connected to the internet. My Roku box, my DVD player is networked. My music player. Even these days, our books are wired. And the problem is that 2/3 of these devices can either make, store, or display images. And your data can get distributed all over the place. So you really need to make sure you know where it all is. And not only is it getting distributed, obviously there's a lot more of it these days. My first digital camera in 1999 was 2.3 megapixels. Yeah, I thought that was huge. And these days, I can shoot tens of gigabytes of raw images a day. And I think we all fall guilty to this is I shoot all that data, I bring it all home, I put it on my hard drive, and I don't throw enough of it away. Because we have these huge disks, huge, more powerful, cheaper disks, we just keep everything. And I'm not horrible. So from 1999 forward, I have 97,000 photos on my disk.
Oh.
That's not bad. My wife Patty has been shooting half as long and she has 150,000. So, it's only going to get worse. There's no way I'm never going back. It's there now. So it's going to move forward with me for the rest of my life and the rest of my hard disk's life. So what to back up to, I've kind of alluded to this already, is I think that the only thing we can back up to these days are other hard drives because the volume of data that is involved. Optical is too small and it's too slow and it's too fiddly. And optical disks are actually good for historical. If you've got really sacred data that you want to put in a bank vault somewhere, buy really expensive optical disks and back up to them and put them away. But for everyday backups, they're just not big enough anymore. I mean, I've already said the online, the cloud is also too expensive and it's too slow. So for the moment, the only thing I can recommend is hard drives. Hard drives come in different forms. So I brought a few here, and we're all familiar with these ones. These are just USB hard drives. So this is a eSATA hard drive as well. So fast enough to back up to. These are really convenient. You can take them to work very easily. Stack them up. These are so cheap these days. If you're looking for a deal, go to techbargains.com, and 2 terabytes is less than $100 these days on Western Digital. Yeah. But they're not expensive. This is another form of USB drive. This is a cradle. I don't know if this is a good way. You basically buy a cradle and then you buy bare hard drives, the same things that you would put in your PC, and you just put them in here. And it's you haven't. This is a really easy way to have lots of disks the same, because what we end up with in our house is a pile of different types of different brands of things, and these things can run pretty hot, so you don't want them like 10 deep all on or anything. You want some air between these things. Some of these don't even have fans. I don't think this one has a fan. The old ones all had fans, but to keep them cool, so they will run warm. My top tip is label all your external drives, otherwise you never know what anything is. So and the other thing is label all the power supplies that come with them. I label them, just put a number 1, and then with a Sharpie on your power supply 1, and you can actually match them together. You've heard of NAS drive, network attached storage. So you can get a drive, and I have some that just look like this, but a network cable attaches to them, so that they don't need to be plugged into a PC. They just need to be plugged to your network. So that on one end of the scale, you have a USB drive. On the other end of the scale, you have a dedicated server. In the middle, you have network attached storage, NAS drives. And this is a fancy NAS drive someone sent me for free. This is called a Pogo plug. It actually doesn't have a drive inside it at all, but you connect this to your network, and you plug a drive into it, and then just by USB, and it'll take 3 drives on it. You attach that to your network, and now any of your machines on the network can see those drives. The fancy thing about this, the Pogo plug, is I can also then access this from outside of my network via the web. So I can put all my data on here and then go to the office and get it even through their website. I can get it through my iPhone as well. I can go onto my iPhone and look at my pictures. At the other end of the scale, we have a real server, or this is a consumer server. This is unfortunately, HP have just pulled out of this market, but this is called Windows Home Server, and it's what we'd call a headless machine. You don't plug a monitor into this, you plug this onto your network, and then you access it through another machine. But it has a hot swappable hard drives. So it's RAID. I don't know. Do you know what RAID is? So there's RAID 0 and 0. Everything's a derivation of RAID 0 and RAID 1. You see this picture up here. This is really popular amongst photographers. This is called Drobo. And this is a RAID array. It plugs into your computer via USB, but it has 4 drives inside it. And the great thing about it is it's RAID. If one of the drives dies, when you look at it from your computer, you see one big block of data. But if we put 4 1 terabyte drives in there, you wouldn't see 4 terabytes worth of data. You see 3, or you see 2.8, I think, something like that. Because what it does is replicate data all the time. If one drive then dies, this light on the front of it goes red, and you pull it out, you put in another one, and it rebuilds the RAID array, and no data is ever lost. So this is a way of having drives fail, but not affect you at all. The same thing with this thing. This has RAID built into it. So if a drive dies on this, it'll light up red, telling me there's something wrong. I can pull it out, put in a new one, and it'll rebuild the array, and I'm up and running. But they're not cheap, and they're fiddly. So they're probably more than most people need. So the machine itself is about $500, $600, and then the drives inside it. So it comes in at less than $1,000. If your data is really precious to you and you're really anal like I am, it's great. But if you're not so anal about it, I mean, that thing there, the Drobo, is $400 and then the drives, and it doesn't run. Well, you have to buy then a box that goes on the bottom of it if you want it to become a real server and attached to your network rather than go for a PC. Let's whiz on quickly. So, belt and braces, we're going to have an automated incremental daily backup, and we're going to have a manual, less frequent backup, and then finally, we might have some core data that we store online or in a bank vault on optical disks. How to do your daily incremental. So, if we're on Windows, we could use Windows Home Server, which is this box, and it will take care of it. Alternatively, what I use is SyncBack, which is a free piece of software that I'm going to quickly show you, and I'll put on our website. So it's free. There's a paid version, but the free version does everything you could possibly need. If you're on an Apple machine, you get Time Machine for free, and we'll quickly take a look at that. But that's going to do your incremental backup for you without you having to do anything at all. So Carbon Copy Cloner. Nice. It took me forever to find that free piece of software that is SyncBack for Apple. Or it has the disk utility now, isn't it? The disk utility itself will do backups or mirrors, I think. But the takeaway point is, don't rely on a manual process. You will neglect it. You will get lazy. The number of people who tell me, I lost the last 8 months worth of pictures because I stopped backing up. Something died. So, yeah. I just have some screenshots of how you do it here. So, some terminology can be a little confusing, but basically you create a profile per backup job. So, basically a profile is a job. And then you schedule those profiles to run. And it's going to walk you through those things. So let's quickly do that. So when you start SyncBack, it looks like this. This is my work machine, so this is not very interesting, apart from you can see I like This American Life, so I'm making sure I'm backing up This American Life. But each one of these is a different job that runs the backup data. And over here we can see when it's going to next run. And here we can see, did it work? Yes? No? Doesn't fail. So we'll talk about being able to monitor this as well. And all of mine are backup types, but there are other types. And if we could see further, we'll see more information. But basically, we create a profile, and you specify your source, which is where the data is coming from. So we were talking about, you've got to know where the data is. So here I'm backing up my application data. On my work machine, I'm backing up my application data. And I'm backing it up, in this case, to a server at work. But this could be a USB drive on my machine. And then we'll leave this as the default, which is include all the subdirectories, because we want to include everything here. Now, there's all sorts of different things here, and I'm just going to show you the main ones that I think are really important. The first one is the Advanced tab, and this is going to tell SyncBack what to do if there's what it calls a conflict. So, and it puts it in English here, what to do if the same file has been changed in the source, which is on our real data, and the destination, where the backup was. So, if I've updated a picture, I've done an edit to a JPEG, I've replaced a JPEG, for example. I want to make sure that when it copies from the source to my backup drive, that it overwrites it. What to do if the file is in the source, but not in the destination. So if I created a new file on my PC, I obviously want to make sure that that gets copied over there. What to do if there's a file on the source, in the destination, but not in the source. So if I've deleted a file from my desktop, I probably want to get rid of it on my backup as well. But you might want to keep it. Some people like to keep them so that even if you delete it on your desktop, it doesn't get deleted on your backup. I just get rid of them. And then the next tab I'm going to show you is the filter. So you can tell it exactly which files to copy, everything in this case, which directories to copy, everything, But here I can specify things I don't want to be included. So I don't want to copy .old files. Some programs create these, which are just files that it's keeping around just in case. I don't want to copy temp files. And you can just filter directories. So I don't know if you know, but when lots of programs create cache directories, which you don't want to be backed up because they're just there to increase the speed of the program. So you would tweak, this is where you go through and you tweak it all the time, just telling it what you want to back up and what you don't want to back up. You want to err on the side of caution. So if it's a bit slower and it backs up too much, that's way better than you miss files. Yeah. And then finally, over here we have the scheduling part of it. We also wanted to tell it what to do it creates a log file at the end of each time it runs, telling you which files it copied, which files it didn't. But I'm telling it, I only want to see this log file if something goes wrong. Because I don't want, and what happens is if I go to my desktop and the browser displays this list of files saying this failed, and I can go through them and just see why. It'll tell me why in a big table. So it just appears in your browser. But the other thing is I can tell it to email that log to me. So even if I forget to look at my machine, it will email it to me if something went wrong, which is really handy. But the important button here is we're going to schedule it after we've created it. So we create a job telling it what to back up from where to where, and now we schedule it. So we hit the schedule button and we tell it, this is when you can schedule anything in Windows, but we're specifically scheduling this job. We're telling it to back up every day. This one happens at 2 o'clock in the morning, but you change it to whatever you want. You can change it to only happen once a week. You can change it to happen every hour if you want. But you schedule it here. You tell it how often to do it and when to do it, and then to do it every day. So you've got to be a little careful about when you schedule this. I shut off my machine at home when I'm not around, but I know it'll always be on in the morning when I'm having my coffee, and I know it'll always be on in the evening. And if it misses a backup job once in a while, it doesn't matter. But if it fails consistently, you'll see in that it should have been scheduled and it didn't happen, and it'll give you a message. You've just got to decide, based on your working practices, when your machine will be most often on. And it can run at the same time as you're doing anything else. The first time I run this, if I've never run this before, it's going to back up everything, and it's going to take hours. But the next time, tomorrow, it's only going to back up the files that have changed, and it'll take a few minutes. Okay, so Apple users, we said, you get Time Machine for free. I don't know Apple very well, but I know Leopard and everything comes with Time Machine as standard. Pretty amazing. Yeah. You can go back through the days, and basically, it's going to work and back up everything. It's going to back up my whole machine, or every disk I tell it to do. And I can go back and say, oh, bugger, I deleted a file last month, but I didn't mean to. You can go back to the month before that and retrieve it. So it's pretty cool, but there are some limitations, which we'll quickly go through. But the easy thing about Time Machine is the setup. Basically, you plug in a drive, a USB drive to your Mac, and when it comes on, you just say, I want to use this for Time Machine. And then there are a few options. We can tell it what not to back up. So the same way as we were filtering before. So all you do is tell it, I want to use this disk for Time Machine. And you can't use it for anything else then. Just use it for Time Machine. There are a couple of provisos in this, in that I've not found out how you can get more than one disk to be used in Time Machine. So I think you can only use one disk. So you need it to be bigger than all the data that you're trying to back up. And Apple will also sell you something called Time Capsule, which is basically Time Machine in a box. It's a little server. Okay, so we're going to quickly whiz through this now. Backing up to your offsite backup. You talked about can it tell the same drive? You can actually, one way that you could do your offsite backup is to switch your USB drive that you're backing up to and take that USB drive away, put in a new one and just start backing up on that one and then switch them over every month. I'm on Windows, and what I do is I have it totally separate from my incremental daily backup goes to this. I do weekly backups to an external USB drive and then take them into the office. So I use SyncBack, just another job that isn't scheduled that I manually kick off. I do the same thing on my wife's Apple, but using a piece of software Steve was talking about, Carbon Copy Cloner, which is available for free from this place. And this you just tell to copy from one disk or several disks to another external drive, and then I take those disks into my work office and put them in a drawer. You can persuade family or friends to store your drives somewhere that you go very often. Even someone here at Photochrome you could swap drives with. Tell them to store it in their basement for you.
When their house burns down,
well, if their house, only if both your houses burn down. So don't give it to your next door neighbor, but the one down there. And then the final thing I talked about was your core data. So my process pictures, I put all of my process pictures on Flickr. But you don't have to. You could put them on Picasa. These days, there's Dropbox, MobileMe, somewhere online that you put pictures that you're really happy with. Maybe you want to share them, so you put them up there and let everyone see them, but maybe not. Maybe you just want to put them up there for storage. You can't put up a raw file. This is just processed files. Yeah. If all else fails, I have got 5,000 pictures on Flickr, and if I lost everything, I can go to Flickr and download. I've not lost everything, I can go back. I'll be upset, but I'll have. And what Flickr is $25 a year for as much storage as you want, so it's a pretty good deal. So I use Flickr for sharing. MobileMe comes with Apple, I think, for a small fee. You get some space, and you can store stuff there. Dropbox is free, or you pay for it, and it actually looks like a disk on your machine, in your My Documents, and you can just drop files into it. Well, the nice thing about Flickr as well is if you use Lightroom, you can just set up an export profile in Lightroom, drop your files into there. It processes them and uploads them for you. So you can do hundreds at once if you want to. And you can set different profiles. So you could have, these are just files I want to back up and I want no one to see. Drop them here, it does it. These are photos I want to share, and it puts them into a public space instead. So quickly, you saw how complicated my system is, but this is my backup strategy. And what you've got to do is come up with something that's hopefully half as long as this. But because I have Macs and PCs, I have a Mac and I have the data stored on all the data that she's working on is on USB and FireWire hard drives plugged into her iMac. Prior years, as I said, are copied to external hard drives, which are then switched off, and then copies. I always buy hard drives in twos, exactly the same, and I take the other one offsite. Automated backup is via Time Machine to an external hard drive, like I think a 2 terabyte hard drive in one of these cradles, so that just runs all the time. And then the offsite backup I run every 2 weeks using Carbon Cloner. I bring in the hard drive from my office, run it, take it back the next day. So that's then offsite. On the PC side of things, the Windows side of things, all my data is stored on internal hard drives in the main machine. My automated backup is via Windows Home Server. My offsite backup is via sync back to external hard drives at all, which I take offsite. Review and revise. When should you look at your backup strategy? And one of them is whenever you add a new hard drive, either internal or external to your system, you should make sure that that's been backed up as well. So it's one of the times that you should look at your strategy, look at your backups. You should look at it at least every 6 months, like a doctor's checkup or something, every 6 months, or a dentist cleaning. If you check your backup strategy every time you get that notice from the dentist that they want to scrape your teeth, you'll be good. So whenever you add a new drive, whenever you replace your computer or get a new one to add to your system, you should look at the backup for that. Whenever there's been an outage in your house, just make sure that things are still running as you expect, because an outage can cause all sorts of problems. Whenever you get a new camera, every 3 years or something, you should make sure that the new workflow that you're going to implement when you've got a new set of raw data and stuff, that still gets covered. And then whenever you change your workflow or your software, you should make sure that the backups still work. And you should test your backup. We just said it's no good if you think you're backing everything up, something fails and you find out you're not. So just, look at those backups via another machine other than the machine you're backing up from. So if you've got a laptop, just plug the laptop into those external hard drives you're backing up to and take a look and make sure that what you think is there is there. Make sure that those scheduled jobs still run. So if you don't have that email telling you that something's failed, you can find out that it hasn't run for the last month. That's not good. So just check once in a while that those scheduled jobs are running. So SyncBack actually tells you, it's got a little icon running in the system bar, and it'll tell you if something's gone wrong. And so in summary, create a strategy, implement it, test and review it, and then you can sleep someday. Very good.